Have you ever held a handful of sand at the beach and wondered how many stars there are in the sky? The number is, honestly, staggering. There are more stars in our observable universe than all the grains of sand on all the beaches on Earth. Think about that for a moment. Each star, a potential sun. Each sun, a potential solar system. And within this cosmic ocean we float on our pale blue dot, trying to make sense of it all. The year 2024 was a time when our understanding took a giant leap. We peered deeper into the fabric of reality, listened closer to the echoes of creation, and began to truly grasp the immense interconnected story of the cosmos. It was a year that reminded us that the grandest truths can be hidden in the smallest particles and the faintest whispers from across space-time. For a long time, the very beginning of our universe was a closed book. The Big Bang happened, we knew that. But the first 380,000 years were a mystery. A time when the universe was so hot and dense that light itself was trapped in a fiery fog. We couldn't see past this wall of fire. But what if we could listen? In early 2024, a global collaboration of radio astronomers and physicists, using an array of incredibly sensitive detectors spread across the globe, announced they had done just that. They didn't hear a sound in the traditional sense. They detected a faint primordial hum, the whisper of gravitational waves, ripples in space-time itself, emanating from the universe's first chaotic second of existence. It was the cosmic equivalent of hearing the thunder from the dawn of creation. Albert Einstein famously called it spooky action at a distance. He was talking about quantum entanglement. It's the bizarre idea that two particles can be linked in such a way that whatever happens to one instantly affects the other, no matter how far apart they are. Separate them by a room, or by a galaxy, and the connection remains. But in 2024, that all changed. A team at the Zurich Institute for Quantum Information, led by the brilliant and energetic Dr. Lena Petrova, demonstrated something revolutionary: the first stable, long-distance quantum entanglement network. Dr. Petrova and her team didn't just entangle two particles. They created a small quantum internet that linked dozens of quantum processors across a citywide fiber optic network. So what does this mean for you and me? Imagine a truly unhackable internet. But with an entangled network, the very act of trying to intercept or measure a quantum message would instantly break the entanglement, alerting the sender and receiver that their spooky connection has been disturbed. By linking smaller, stable quantum computers together, we can create a much larger, more powerful distributed quantum computer, capable of solving problems that would take a classical supercomputer billions of years. Every second, the sun fuses about 600 million tons of hydrogen into helium. This process, nuclear fusion, is what powers our star and honestly all the stars in the sky. It's the ultimate source of clean energy. For over 70 years, scientists on Earth have been chasing a dream: to replicate this process, to build a miniature star in a bottle and harness its power. But in the summer of 2024, the International ITER project in France announced a historic milestone. They achieved sustained ignition. The moment came on a sunny afternoon in July. Inside the massive donut-shaped machine called a tokamak, powerful magnetic fields squeezed a cloud of hydrogen isotopes, deuterium and tritium, to unimaginable pressures and temperatures. But this time was different. The fusion reaction became self-sustaining. For a full 37 seconds, the artificial sun burned on its own, producing 10 times more energy than was being used to maintain the magnetic field. In the control room, a hush fell before erupting into a joyous celebration that echoed around the scientific world. The director of the project, Dr. Kenji Tanaka, a veteran plasma physicist, described the moment with tears in his eyes. He said it was like watching a child take its first steps. Our universe is expanding. We've known that for about a century. But in the late 1990s, we discovered something shocking. The expansion isn't slowing down due to gravity, as everyone expected. It's actually speeding up. Something is pushing the universe apart, an invisible, mysterious force we call dark energy. In 2024, a new space observatory, the Euclid telescope, provided the first tantalizing clues that pointed toward an answer. After mapping the positions of billions of galaxies over a vast swath of the sky, its data began to show something remarkable. The Euclid team, a European Space Agency mission with contributions from NASA, was led by cosmologist Dr. Isabella Rossi. The key finding announced in late 2024 was that the strength of dark energy doesn't appear to be constant. The data suggested that dark energy was weaker in the early universe and has been slowly growing stronger over the last few billion years. For more than half a century, our digital world has been built on silicon. The silicon chip is the foundation of our computers, our phones, our entire technological civilization. But we're reaching its physical limits. We can only shrink transistors so small before quantum effects start to cause problems. In 2024, a materials science lab at the University of Manchester, the very birthplace of graphene research, unveiled a stunning solution. They created a new two-dimensional material they called graphene nitride, a perfectly engineered 2D semiconductor. The team, under the guidance of Professor Wei Zhang, had been experimenting with combining different 2D materials like Lego bricks. They discovered that by arranging atoms of boron, phosphorus, and nitrogen in a specific honeycomb lattice, they could create a material that was incredibly thin, just a single atom thick, but also had near-perfect electronic properties. Computers built with graphene nitride processors could be thousands of times faster and more energy efficient than today's best machines. This material could also lead to transparent, flexible electronics. We could have screens that roll up like a scroll, clothes with embedded computing power, or even biomedical implants that integrate seamlessly with the human body. In 2024, the creation of its 2D successor set the stage for the technological revolutions of the 21st. The year 2024 was one for the history books. We listened to the echoes of creation, tamed the fire of the stars, and built bridges into the quantum realm. We peered into the nature of the void and designed new materials atom by atom. Each discovery was like opening a door, but in science, every door you open reveals a hallway filled with more doors, more questions, more mysteries to explore. The breakthroughs of 2024 didn't give us all the answers. Instead, they handed us a new, more exciting cosmic to-do list. The detection of primordial gravitational waves confirmed inflation, but now we must ask, what was the inflaton? The field that drove this incredible expansion. The success of the first long-distance quantum network opens a new frontier, but now we must figure out how to scale it globally. These are the grand challenges for the next generation of scientists, engineers, and dreamers. The discoveries of 2024 have set the stage. They remind us that we live in a universe that is still largely unknown, filled with wonders waiting to be uncovered. They affirm that human curiosity, when combined with collaboration and persistence, is the most powerful force we know. We are explorers on a cosmic shore, and the ocean of truth lies all before us. The questions are bigger, the tools are sharper, and the adventure has just begun. The cosmos awaits.